Okay, just to finish up this last part, I don't know 100% where that video cut off, but we have to have square brackets at all of those parts there because it says where is it greater than or equal to. Greater than or equal to means that we are including all of those pieces there. Okay? All right. Then the next question that it's going to ask you, sorry, got to click through these, is it wants to know where is f of x less than 0? Okay, so less than 0 is the opposite. So less than 0 means it wants to know where are my y's below that axis there. So if I look at my picture on this, in this section right here it's below, and in this section down here it is below. Okay, so again we're going to be using intervals. So in this section right here we can say that our graph is below. I'm going to be from negative 5.1 all the way over to negative 2. Negative 5.1 to 2. In union with, I'm going to be from my positive, from positive 1.9 all the way over here to 8. Okay, so I'm going to do 1.9 to 8. Okay, now this one's going to be a little bit different because if you look, it's just a less than sign. Since it's just a less than sign, we're not including these values. I'm going to have a parentheses here and a parentheses here. I'm going to have a parentheses at 1.9. At 8, however, I'm going to have a square bracket. And the reason is, if you guys look, at 8, we're not on the axis. At negative 5.1, I'm on the axis. At negative 2, I'm on the axis. At 1.9, I'm on the axis. And we're not including those that are on the axis. But 8, I'm down below. So 8, I am going to include. Okay? So that concludes what we're doing with the visualizing functions. Sorry I couldn't get in one video. Now let's look at even and odd functions. Again, guys, I'm going to go through this fairly quickly here. What you need to know about even functions is that they are symmetric with respect to the y-axis. So if I was going to draw you a couple even functions, your parabola is an even function. It's symmetric with respect to the y-axis. Your absolute value function is an even function. It's symmetric with respect to the y-axis. Okay, we're going to skip these here. Don't worry about it. Don't worry about this. Then we're going to be here our odd functions. The odd is our other option. Okay, odd means that they are symmetric with respect to our origin. Okay, so functions that are symmetric with respect to the origin would be our cubed root function, or sorry, not our cubed root, would be our cubed function. Okay, your cubed root function is also symmetric with respect to the origin. A different one that you could put up there if you wanted to, our reciprocal function, it's symmetric with respect to the origin as well. Okay, so what we're going to do is, because last time we were visualizing which of these were symmetric with respect, I'm sorry, I'm lost. Okay, I'm back. Last exam, what we did was we looked at a picture, and we were saying if it was symmetric with respect to the x-axis, y-axis, or origin. This time what we're doing is we are going to be looking at an equation, and based on the equation, we're going to be able to tell you guys if it's even, odd, or our big question here, if you look at the slide that I'm on, says, are all functions even or odd? And the answer is no. Sometimes functions are neither. Okay, so what I'm going to do is I'm going to work through these examples here with you guys, and we're going to be able to tell you if they are even, odd, or neither. Okay, so the way that we tell if a function is even is you need to prove that f of x equals f of negative x to show you if it's even. To show you if it's odd, you need to prove that negative 1 times f of x equals f of negative x. Okay? And we're going to go through step by step. Essentially, what your first step is your first step is to test if it's even. And the way that we do that is we're going to look at f of negative x. Okay? If f of negative x matches f of x, okay, we're going to essentially plug in negative x to our function. And if it matches f of x, then boom, it's even, you're done, you don't have to do anything else. Okay? So if I look on this next one here, let's go to the next page. Let's look at this one here. Pause it if you need to get to this spot, but I want you guys to do f of x equals x squared. So my first step when I solve this problem is to go f of negative x. And I'm going to plug in a negative x into this function. So instead of an x here, I've got a negative x. Okay? Then I'm going to look, negative x squared. What's that squared going to do to a negative? It's going to get rid of it. If I have a negative x times a negative x, that's going to give me a positive x. It's still squared, minus 5. And holy biscuits. Those two are the exact same. Since those two match, you guys can say that this function is even. Okay? So if your f of negative x matches your f of x, which it did in this case here, it's even. And you're done. You don't have to do anything else. Okay? Let's go back then to this slide here where I was talking about our odd functions. Okay? Let's say that these don't match here. Say that those don't match. What's our step 2? Well, our step 2 is going to be to test if it's odd. Okay? So how do I test if it's odd? Well, you've already found f of negative x. We've already found f of negative x. So now you need to take negative 1 times just your regular f of x. Okay? And if this matches this one here, then it's odd. So let's try one that's going to be an odd function. Let's do this very first one here. Again, pause it if you need to. We're going to do f of x, we're going to do f of x equals 4x cubed. So starting out on this one here, your first step is the same even if you think it's even. I'm going to check negative x first. That's going to give me a 4 times negative x cubed. Okay? Now, is that cubed going to get rid of the negative? No, it doesn't, because that's a negative x times a negative x times a negative x. So those three negatives end up making it be negative. So this is technically now a 4. Whoops. This is technically now a 4 times a negative x cubed, which we would just write as negative 4x cubed. Okay, so just like before with my even functions, now I'm going to look. Does this match this? No, it does not. This does not match this. And what that means is it's not even. That's fine. This one's not even, not a big deal. What I need to do next is I need to test to see if it's odd. And to test to see if it's odd, I have to know my f of negative x, which I've already found. So now what I need to do is I need to take negative 1 times my f of x function. Well, what's my f of x function? I'm going to need to take negative 1 times 4x cubed. Okay? So pretty simple. If there were a couple terms here, you would have to distribute that negative 1, but for this one I don't have to. And when I do that, I find that negative f of x equals negative 4x cubed. Negative 4x cubed, negative 4x cubed. Those two match. So it's odd. Okay? So again, just a quick run through. If these two would match, it's even. If these two match, it's odd. Let's try another one here. We're going to go to the next slide. Let's look at this one over here. F of x equals x cubed minus 1. F of x equals x cubed minus 1. I'm going to go ahead and I'm going to test f of negative x. Let me change that color there. F of negative x equals negative x cubed minus 1. that cubed is not going to get rid of that negative. So this just ends up being a negative x cubed minus 1. Do these two match here? No, they don't match. This one doesn't have a negative. So that means that this is not an even function. Okay? Now I'm going to look at, what if I took negative 1 times my f of x? Okay, well if I take negative 1 times my f of x, I'm going to take negative 1 times x cubed minus 1. Distribute in my negative 1. That gives me negative x cubed plus 1. Okay, so now I'm going to check. Does this one match this one? Whoops. They do not match. Okay, so these two don't match, so it's not even. And these two don't match, and that means that it's not odd. So if it's not even and it's not odd, our answer for this one is neither or neither. Okay? I know we didn't get through a lot of those, but I think those examples should help you guys. If you have any questions, feel free to email.